So I'm actually online. So yeah, like I said, I just spent about 20 minutes talking to myself because I didn't realize it had gone offline or something. So let's begin. Just waiting for that. Just confirmation that it's going from YouTube to see that my screen comes up. Yeah, you'll see me in a bit. There we go. Yeah. Hey, thank you. So, I'm going to go through what I did. Like I said to the empty room earlier, which I'll delete now, I'm starting to work on a garbage collector. And my intention is to write all of the garbage collector over the stream, and just come to it as a project each Monday night for a while. Because I'm guessing that a lot of people haven't seen garbage collection or what that's like. So we'll try that. So we've had a look in the interpreter at one of the sites that allocates memory, and we've created a function for it to call here, pzgcalloc. There's the declaration. I had nice tips on C and everything. Actually, that's quite frustrating. And there's the definition. I've got it in 2 windows there. Anyway, let's open runtime p. Let's actually... what I need is a heap. So we're going to have a heap object rather than reference it from static data. And here's where we call it. So we need to pass in a heap. So I need to create a variable to refer to the heap, local in this function. So go up to the top. Initialize it to null. So what I want to do, setting up some of the environments. I might as well make it one of the first things I allocate. Heap is pzgcint, the new function that I created above. If heap is null, what we're better off doing is saying null is heap, so that we never confuse ourselves with double equals and single equals. Not that that's happened in a long time. And printf. So if we couldn't initialize the heap, then say spell in Australian. We should abort. Or how do we actually handle errors in this function? Do we just return then? What does end do? The end instruction goes to finish. And finish, that's actually really good to know. So wrapper proc, we have to initialize these to null so that we don't break when we handle errors there. Oh, hey, and welcome new viewer, and I'll guess I'll see you another time. So I'm pleased that you were able to drop in. So, well, it'll be available after I'll make the recording available later. So I need to make sure that these are initialized to 0, because what I'm going to do in finish, I realize I'm jumping all over the place here, but what I'm going to do is only free these if they're not null, so that regardless of when we have an error, we can always go to finish and jump to this label. So if wrapper proc is not null, I updated the coding guidelines. It says I can't be lazy about this and always have to compare it to null and make a Boolean expression there, even though it would work if I took a couple of shortcuts. So return stack and expression stack. You also have to initialize to null. Then when I get here, I fail to allocate heap, I can go to finish and need to set ret code. I don't know what an appropriate error is. We should consolidate that at some point, and like for whether it's the user program. Since it's not the user program, let's pick a fairly high number. Since it's not the user program's error, let's do that. For now, those are probably all over the place. And now we have to handle the other ones. If null is not return stack, and if null is not expression stack, and finally the heap. You know what? Yeah, we don't need to do this if we're in a debugging mode, so what I'll do, I'll add a little to-do note. To-do, you can skip this if not debugging. If null is not heap. PZGC free. Right. So we have to call our own free method here. And that means I need to write one. But now that should be fairly good to go. Let's declare one. Void PZGC free. PZ heap. I'm passing parameters. How do I want to introduce some of the more basic things of what I'm doing, just in case there's anybody watching who might be learning their very first programming language. So you tend to pass parameters when one of these callees, something that's being called, needs some information, in this case the heap. So it needs PZGC free, needs a pointer to the heap. Void caps lock. Void PZGC free PZ heap. Right now nothing's implemented there, and this program will crash still. Make a test. Oh, it still doesn't work. Oh yeah, I should do that other thing. So because it's a PZ heap. Yeah, that's better. Make a test. Yeah, look at that. The only programs that actually work are those that don't, that test whether something can't be compiled. Because this returns null and always catches the error below. So now we need to allocate a basic heap. We're going to need to define one. Struct PZ heap s. And what does a heap have? I don't know yet. Does struct end in semicolons? I don't remember. Yes, and I'm implementing a garbage collector using the system allocator for some of its structures. That's fine. I'm allowed to do that. Well, I will do 3. There's no point delaying that and explaining it later. So star token there. Expected equals y. Y. Line 16. Is that line? There. Yeah, because we do need a semicolon at the end of structs. Get matching brackets. And now, yeah, now we're back to where we were, where we still can't allocate memory. So what we want to do is do some work to set up memory allocation. What I want to do for that is, there's 2 ways to implement to get. Yeah, we're going to ask the operating system to give us a big lot of memory, and then from that we're going to divide it up and implement our heap. To ask the operating system for memory, there's 2 ways. SBRK, which you can see it here. You ask it for how much more memory you want, and it returns an address pointed to that memory, but it all ends up in one place, so it's easy to get fragmented, and it's not exactly what we want. It is more traditional though, and possibly more portable, but what I'd prefer to use is map. So map some memory, or memory map, which will allow you to, which will place it in a random place within your address space. You can set protection flags on it, so you can get memory of different types, and you can ask for it to be backed by a file descriptor if need be. And you can unmap it later on when you're finished with it. So you can put SBRK, you can use that to move the memory allocation, the break at the end of your heap backwards, so you freeze this memory, but that's not what I want, because that you can't control which memory is freed more easily. This is a bit more of what I want. So I'm going to implement the most stupid memory allocator ever. With void pointer memory set the memory to mmap. We need, I think you set the address to null. I'm going to read this man page. If address is null, then the kernel chooses the address of where to create the mapping. This is the most portable. That's what I'd like. Yeah. Map anonymous below are initialized using length bytes starting at offset offset if the file or other object refers to by the file. So we want for the length parameter, we're going to PZGC max size. So this is going to be one of the. We're just going to have a fixed heap size and not vary it. And we can define that up here. Max size should be, how about a megabyte? Doesn't seem like a lot, but it'll be enough for now. I'm actually going to make it smaller eventually for one of our tests. So the next parameter is the protection, I think. Yep. And we want read and write. Prot read and prot write. I believe it's a bit field, so I've turned caps lock on and that never helps. Prot read and prot write. Since it's a bit field, we OR them together to get the right values. Flags, we share the mapping, we create a private mapping. Updates to the mapping are not visible to other processes. I think I want a private one, but I don't know if I actually need to specify anything for an anonymous mapping, which is what I want. We don't need it linked to a file. Not carried through to the underlying file. It is unspecified whether change is made to the file after the map poll. Yeah. Both of these flags are described in addition, 0 or more of them. Do I have to specify one of those? Alright, the flags argument I'm reading here now determines whether updates to the mapping are visible to other processes mapping the same region, or whether updates are carried through to the underlying file. This and whether this behavior is determined by including exactly one of the following fields in flags. Okay, so I need one of them. It might as well be private. In addition, you need these things. Put the mapping into the first 2 gigabytes. I don't need that. Map anonymous, I do need. Map anonymous. I can never spell that. Y. Yes. That means that rather than be linked to a file, it's going to map this to dev0, and we'll initially get memory full of zeros, which is what we'd like. Its contents are initialized to 0. The FD and offset are ignored. However, some want it to be -1, so I'll do that. Should ensure this. Yeah. The use of map anonymous in conjunction with map shared is supported only by Linux since then. Yeah, I don't need that. I don't need deny write. I don't want an executable. Yep. Grows down, used by stacks, I don't need that. I'm not going to get into huge TLB, even though some of these could be useful for performance later on. They're likely not so portable. So, and I just don't need them right away. I don't need locked. I don't need non-blocking. It doesn't even make sense. No reserve. Do not reserve swap space for this mapping. When swap space is reserved, one might get seg faults. Right, if no physical memory is available. I'd actually prefer that, but again, I have no idea about the portability of that option. Yeah, none of these other things I don't know. Yep. So, and the last 2 parameters are the file descriptor and the offset, which said -1 and 0. let's check how this fails. So what happens when we can't get memory? So return value. On success, mmap returns a pointer to the mapped area. Yep. On error, the value map failed, that is void pointer to a -1, is returned and error no is set to indicate the cause of the error. So I want map failed. If map failed, memory then p error, and I forget the syntax for that. So these are all the errors that can happen, and what we're going to do is just use p error to print whatever one is happening. P error, so we give it our message. Don't think we even need to give it. Yeah, we don't need to give it error now. So all I want to say is tell it that it's mmap that failed. Return null. Oh, and free heap. Now we're missing one thing, and that is what do we include to get access to mmap? sysmman. And p error. stdio. Okay, we've got some errors. Heap has no member. Didn't I make that? Memroy. That'll help. Map. It still thinks undeclared. Too many arguments to function mmap. That's interesting. Oh, because those should be in the same field, and it thinks I spelled anonymous incorrectly, and I have no idea. Map anon y mous. Map ANONYMOUS. Can anyone see where I'm going wrong? ANONYMOUS. ANONYMOUS. Yeah, I don't see that that's got a problem. Am I missing an include? In conjunction with map shared. No, that's different. See notes for information on feature test macro requirements. Blah 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 blah. Example. Note. Bugs. Notes. In some hardware architectures, prop write implies prop read. It is architecture dependent whether prop read implies exec or not. Portable programs should always set proc exec. They intend to execute the thing. Portable when you read mappings. Address is 0. And omit fixed. Certain flag constants are defined only if either BSD source or sysvid source is defined. Requiring GNU source also suffices, and requiring that macros specifically would have been more logical, since these flags are all Linux specific. The relevant flags are... they're all Linux specific? I find it hard to believe that anonymous mappings are Linux specific. Well, let's just use one of the BSD source. It wasn't clear which one I need, so let's see what we've got. POSIX C source. I have no idea when it comes to feature macros. Feels like strange incantations. I mean, I know that they're for a reason, but I don't understand how they actually help. I know what they're supposed to help with, I just don't see how they achieve that. No, it's still not working. Oh, because we need to add it. Our C flags doesn't add to... oh, that's kind of dumb. I've got standard C99 there, and define C99 source here, but I don't know why. So we might have to check on that. BSD source. Yeah, so it compiles now, and I wonder where it doesn't work. So let's go back to our test here. Yeah. Invalid write of size for address 8. So we've got a memory bug here. Address 8 is not on the stack on the malloc or recently freed, so it doesn't know why we're writing to that. Well, that's obviously a bad address. I wonder why it's doing... yeah, it's still because of this. That's fine. So that code appears to be working. We appear to be getting a lot of memory. Let's now allow it to allocate memory. this is why it's a really naive allocator. Heap pointer is heap memory. We should also unmap the memory. Let's find out how unmap works. The munmap system call deletes the mapping for the specified address range and causes further references to addresses within the range to generate invalid memory references. The region is also automatically unmapped when the process is terminated. On the other hand, closing the file descriptor does not unmap the region. The address must be a multiple of the page size, but length need not be. All pages containing a part of the indicated range are unmapped, so subsequent references to these pages will generate segfault. It is not an error if the indicated page does not contain any mapped pages. That's fine. So what does it return? On success, munmap returns 0. On failure, it returns -1, and error no is set. If there is an error here, we're just going to continue anyway, because we don't need the result. We don't strictly need it to be unmapped to be able to keep going, and we're finishing anyway. Yeah, we still have that error. I shouldn't have been surprised. So now we have a heap pointer. So when we want to allocate memory, void pointer memory or cell, it's called a cell, heap pointer. We're just going to do some bump pointer allocation. We'll worry about freeing memory later. So heap pointer plus e. So add it, and then actually is itself plus size and pz round or align. I wonder what I forget what my alignment functions are called. Runtime pz common. Not in there. Where would I have put? No. Well, I know that the main thing calls it. I know that it aligns memory. So whatever. It's just local. No, it's not pzutil. We can. Oh, I see. It doesn't need a pz prefix because these things are only included by source files, which means they never get exported. That makes sense. but could be dangerous. So now we should be back to having something that works. No? Oh yeah, we need to include it. Duh. That's interesting. What am I doing? PZ run list one dot PZ. Make list one PZ. Segmentation fault. I wonder what's happening. It's not clear to me where this goes wrong. So using the debugger, we find that dereferencing the expressions, no, the address. Is that the problem? Or is it the expression stack? Shouldn't be that. Looks like it might be the address there. I don't know. So let's dereference the address. We first need to cast it to something other than a void pointer and then dereference it. Cannot access memory at address 9. Oh, because I've got the wrong value there. Yeah. Is that the memory we attempted to allocate? Let's print heap. Print. Huh. Why in one of them does the address look shorter here, like a 32-bit value, while here it's a lot longer, like a 64-bit value? Is that the problem? Is it that our runtime system can't handle 64-bit addresses for some reason? What have I done elsewhere to cause that? So to test for that, let's try, because we saw in the mmap man page, map 32-bit. Let's try that. Try getting our memory to stay within the first 32 bits. And see if it still has errors. Because then we know what we're doing somewhere is casting it down. Yeah, that looks good. Well, it didn't crash. I don't know if that's what that program is supposed to do. So let's try that. I'm just going to look at the time. Okay, it's 10 o'clock. I'm going to keep going for another 20 minutes. Or until we maybe we'll keep going until there's a natural place to stop while writing this allocator. And we'll get to how you actually lay out a heap free memory next time. Hopefully. So we've seen the mmap system call. We know that we've got a problem. We might leave that there and debug that. Do you think we can solve this bug in 20 minutes? That would be a nice place to stop. So yeah, so I'm going to try and solve this bug with my heap sizes and 32-bit values in 20 minutes. So my void pointers, these should be well and truly 64-bit values. So heap memory should have no trouble doing that. This GCalloc should return, sorry, this should be well and truly 64-bit values. Is the problem these casts in a line pointer? Let's take a look at this code. Is something here truncating the value? The best way to tell is with a breakpoint. Actually, so we'll remove map 32-bit, build it again, run the debugger, run list1tz. Yeah, that crashes. Create a breakpoint at tzgcalloc. Run it again. Restart it. Print heap. That looks sane. So next. Print cell. That's a full value. Return. Let's actually check that we can dereference cell properly. Print. Yes, we can, and there's a 0 in that memory. That's fine. So cell is pointing to the correct memory. Next, next. Now, when that code returns, that doesn't make sense. No, that's okay. Okay, let's go to that line of code and see that we are where we expect we are. Because I think we've just allocated the memory and now we're back in the interpreter. Line 678. I'm trying to narrate as much as possible about what I'm thinking, but I'm sometimes forgetting and going silent. It's like being nerd sniped by a bug, and I have to think about it and I forget to tell you what I'm thinking. Run generic Was it 687 or 678? No, that's it. Good. Okay, we've just allocated the memory. We're about to put this value into the expression stack. Yeah, the expression stack pointer should be a void pointer, so that should be okay. I rubbed my eye before and I pushed something into it. Now it hurts. Okay. Yeah, it's a void pointer, so that should be fine as well. So let's do that. Next. And now I'm going to look at the expression stack. Print. That was a pre-increment operator, so I'm going to look at the current ESP value. What is the pointer? Yep, that's cool. That is the same value. So now we're here. Next. Next. Read the next instruction. We're stepping through the interpreter. This is actually kind of nice. If you read my recent blog posts about how interpreters work, now we're stepping through exactly how the interpreter works. So we've read the next token that we want to execute, which is store 64. So store a 64-bit value somewhere. Move the instruction pointer forward, switch on the token, and now we're at line 792. Here, doing store 64. So we're getting a value, an immediate value. First, we're aligning the instruction pointer, so we're going to read a 2-byte value out of the instruction stream and then move the instruction pointer forward again. Our current value is still on our stack. We want to get to here, where we're adding it to offset, which is a 16-bit value. That could be where we're going wrong. If something about adding a 16-bit value to a pointer. I don't know what C will do when you do that. So next. So does offset is 8. And our stack pointer should be just the same as before. We can check it afterwards actually. Next. Let's see what address is. Yep, okay. That was okay. Oh, I see. Now we've read that address. Where we're now storing something from the stack to the address in memory, which succeeds. And moving the address back in the expression stack one thing forward, and then we're going to pop the topmost thing off the expression stack. And now we should still have that same value at the top of the expression stack. It's just moved one position and the stack pointer's moved back, and that's true. So next instruction. I can also enable tracing and have a look at all the instructions as they get executed, if this is not completely clear. So 349. You know what, I might do that because it could be quite a few instructions before I find the right place. So let's enable tracing. Again, in the make file where we configure everything with having to do with everything. Enable tracing by uncommenting that option. Let's keep that open. No, let's keep that open. Tests valid. Use runtime pz run list1.pz. It is at the time when that crashes, what is the instruction? Let's try again. Oh. Went too far. Run the program again with our breakpoint disabled. Load 64. 742. Again, we're adding an offset. Okay. We should be able to read. Yeah. We should be able to check this value that is on the stack, whether we expect it or not, because this write won't have occurred yet at the time when the program crashes dereferencing this. Yeah, and it's the shorter value there on the stack. So how did that get there? We might be getting different values each time, but we're seeing here 9040. So what I'm looking at here is whether this addition changes the value of the address, or whether it was actually bad when it was sitting here on the stack. It looks like it was actually bad when it was sitting here on the stack. So it was possibly in a previous instruction that we messed something up. At least for this one, this is the bad value here. And 64. Is it our implementation of tag pointers? It could be. Yeah. If I knew which procedure we were actually executing, this would be a little easier. So we've got this value. So we've obviously called into some procedure. There's this value on the top of the stack. It is, what are we doing? We're loading an immediate 64-bit value of 1, 2, 3, 4, 5, 6, 7, 8. Why are there only 8? They're called nibbles. A half a byte is a nibble. It's a really arcane thing. Why are there only 8 nibbles for a 64-bit value? That is not a 64-bit value. So when we AND it to handle our tagged pointer implementation, we get a weird value here. Is that what's... and swap. Why is it swap? Then load. And then return. Then that is... okay, I don't exactly know what's going on there, but that looks like the problem. The only reason I remember doing that... yeah, it's probably tag pointers. And that immediate 64-bit value is the problem. So if I knew which function I was in, this would help, but I'm guessing that's where it is. Runtime PZ built-in. Int string free, set environment, get time of day, concatenate string die, and make tag bits. So here's our thing, here's our write instruction. Take a word and a primary tag and combine them. This is, yeah, okay, that's not it. It'll be possibly when we're pulling apart a tag. Because I think I've got a clue of what's happening, but I'm going to try and find it first before I try and explain it. Yeah, this could be a problem. Is that the code? I don't believe that's the code that's being executed, but we may have to come back to that one as well. Write instruction. Yeah, pick. Yeah. I think this is the problem here. Yeah, this is likely to be the problem. So right now there's a limitation where I can only load immediate 32-bit values. There's only certain ways of expressing some instructions. It should be more. So, and it might be that our load code is not extending it. Is not doing the sign extension properly. And why would it for a pointer? Normally, right? Wait, what? PZ table. Yeah, this is exactly the problem. We're loading a 32-bit value and relying on write instruction to sign extended, when write instruction neither doesn't really specify. I've made it so it doesn't specify whether it does sign extension or 0 extension. Let's see. Select immediate type, immediate value. Yeah, that won't do sign extension. That is a problem. So sign extension is where if the sign bit is 1 or a 0, then extending the value from, say, 32 bits up to 64 bits, which is what this code is doing, gets it wrong. Sign extension is where you'll make sure that the sign bit is correct after the number becomes, say, 64 bits. 0 extension is where that number will always be 0. So which is what you do with unsigned numbers. Now we need to do this. In fact, we're not even handling this correctly. I don't think it's... Yeah, because this is mask... This is... Yeah, because this is the way it is, we need to sign extended. So what I'm going to do is add extra bytecode here to handle that. So first, don't do any kind of extension when you're simply loading a 32-bit value. So this can't make a mistake in that code. Instead, let's see, 32 to pointer. No. I see the problem. If def, well, if we're on a 64-bit machine, which let's assume for now that we are, I'll come back. We're actually going to have to test both 64 and 32-bit platforms now. Does that instruction even make sense? Here's EW32. Right, my phone is ringing, so I better end the stream now. But I think that's the problem, and we'll catch up later.